talk about 13.2, which is basically going to answer the question, what is a radian? So first of all, let's do a little bit of reviewing. If I have the cosecant of 75, how do I put that in my calculator? Because I have no secant, cosecant, or cotangent buttons. So cosecant is the reciprocal of sine. So that means 1 over the sine of the angle, which was 75 degrees. So making sure my calculator is on degrees, I'm going to type 1 divide sine of 75. And I get 1.0353. So the secant of 155 is the reciprocal of cosine. So that means 1 divided by the cosine of 155 degrees. And I get negative 1.1034. Remember that I said our main focus today is to discover what a radian is. So before we can do that, we're going to have to talk about some general angles and what that means. When you draw an angle in trigonometry, you must draw it in its standard position. Its standard position is an angle whose vertex is at the origin, and its initial side is on the positive x-axis. Initial side means beginning side. So do you notice here, I have the initial side on the x-axis. That means the terminal side will thus fall anywhere within. So on ours, our terminal side fell right here. That is our ending side. And that is how you draw any angle in standard position. Always start at 0, 0, out to 0 degrees, and then go anywhere beyond there for your terminal side. I'd just like to review that where we're starting here is 0 degrees. Up to here would be 90 degrees. Continue over to here would be 180 degrees. Over to here, 270 degrees. And one full circle, one full cycle around is 360 degrees. So any angle will fall between 0 and 360 degrees. Note that all positive angles rotate counterclockwise. That is this way around. Negative angles then rotate clockwise. That would be this way around. So down here you can see I have a positive 130 degrees and I show the rotation going this way. I would like you to show the rotation inside your angles. Then I have a negative angle, also starting its initial side here, going this way, and notice the rotation is downward. That is a negative 75 degrees. Then we have coterminal angles. They are angles who have a common terminal side. We find them either by adding 360 or subtracting 360, sometimes multiple number of times. So let's take a look down here. I have my initial angle of 135 degrees. If I continue to spin all the way around again, I have a coterminal angle. So to go all the way around again is another 360 degrees. So if I would add 360 to that, I get my 495 degrees. If I decided to go around again, I would add another 360 degrees. And that would give me 855 degrees. Or I can go in the negative position. Again, this was my original angle. So if I go backwards 360 degrees, it would also be a coterminal angle. So my initial angle was 135. Go backwards means subtract 360. That brings me to my negative 225 degree angle. So coterminal means they have the same terminal side, just how many times you rotate around. So notice we are either adding 360 or subtracting 360. Just to refresh your memory, on any given axis, it is divided into 4 quadrants. We call this quadrant 1, quadrant 2, quadrant 3, quadrant 4. If you follow them around, they form a C for a Cartesian coordinate plane. So let's try drawing a few angles. The first angle they want us to draw is negative 120 degrees. So here would be our initial side from 0, 0 out to 0 degrees. Negative means I start here and go this way around. To here is 90. I need 30 more degrees. So that would be here. If I think of this, 45 would be right down the middle. So 30 is going to be back a little ways. And notice that I have shown the rotation inside the angle. So that is a negative 120 degree angle. The next one asks us to do 400 degrees. So again, our initial side. So if I start here and I go all the way around, that brings me to 360. I need 40 more. So if this is 45, 40 would be about right there. So I'm going to go up to there. And notice I show the rotation all the way around once, and again that far. That gives me 400 degrees. Now the next question says find one positive and one negative angle of a coterminal. So A, our given angle, is negative 100 degrees. So if I want to go positive, I'm going to have to add 360. So if I add 360, that brings me to 260 degrees. There's my positive angle. Again, I started at negative 100 degrees. If I want negative, I'm going to have to subtract 360. So that brings me to negative 460 degrees. And there's my negative angle. Now B starts at 575. If I want a positive, I'm going to have to add 360. So it gives me 935 degrees for my positive. I started at 575 degrees, and I'm going to have to subtract 360. That gives me positive 215. So this would also be a positive angle. I need a negative, so I'm going to have to subtract 360 degrees again. And that brings me to negative 145 degrees. There's my negative angle. So see what I mean about sometimes you have to do it multiple times? All right. Now we're going to take a look at what a radian is. So the angle made when the radius is wrapped around a circle, that is what a radian is. The angle made when the radius is wrapped around the circle. So if you watch this little video, there's the radius wrapped around the circle. And that gives me 1 radian for there within. I'm going to do that again. There's the radius wrapping around the circle. It ends right there. So within that area is 1 radian. So if I continue to wrap that radius around, that gives me 1 radian, 2 radians, 3 radians, and just a little bit more to get over to 180 degrees. So pi radians reach 180 degrees. So if I take 1 radian, it would be equivalent to 180 degrees divided by pi. So a radian is the area inside from wrapping a radius on the outside of the circle. So 1 radian is equal to pi over, 180 degrees over pi. So if I take that 180 degrees and divide it by pi, that actually comes out to be about 57.3 degrees. So I took this radius, wrapped around the outside, it brings me to about right there. So this is 1 radian, which is about 57.3 degrees. It is exactly 180 degrees divided by pi. So if it took me pi radians to get over here to 180 degrees, to go completely around another 180 degrees would bring me back to 360 degrees. That would be equivalent to 2 pi radians. So let's see if we can figure out how many degrees 0 degrees would be in radians. 0 degrees is equal to 0 pi radians. 90 degrees, well, if I take my 90 degrees times my ratio, it's either 180 degrees over pi or pi over 180. Since this is degrees, I want my degrees on the bottom and I'm pi on the top. So my degrees will cancel. 90 and 180 reduce to 1 and 2. So that is equivalent to 1 pi over 2. 180 degrees was equal to pi radians. 270 degrees should be 270 degrees times the 180 degrees on the bottom, pi on the top. Again, the degrees cancel, the zeros cancel. 27 and 18 both divide by 9. That gives me a 3 and a 2. That gives me 3 pi over 2. 360 degrees all the way around was equivalent to 2 pi radians. Well, how about if we're going the other way? Pi over 4 radians. So this time I'm starting with pi over 4. So this time when I multiply, I want my pi in the denominator, so my pi's reduce, and my 180 degrees in the numerator. That way it will be end in degrees. So here, my pi's reduce, and 4 and 180 reduce to 45, so I get 45 degrees. Let's try pi over 3. Again, I want the pi in the denominator, so the 180 degrees is in the numerator. The pi's reduce, the 3 and the 180 reduce, and I get 60 degrees. Let's try pi over 6. That gives me 30 degrees. How about 2 pi over 3? The pi in the denominator, the 180 degrees in the numerator. Pi and pi reduce. 3 is 60. 2 times 60 degrees is 120 degrees. And 3 pi over 4. Again, pi in the denominator, 180 in the numerator. Pi and pi. 3 times 45 degrees is 135 degrees. Okay, let's try a few more. Let's just refresh our memory that a radian will be equal to 180 over pi, and a degree will be equal to pi over 180. So here we have 320 degrees. How many radians is it? So 320 degrees is what we're starting with. So the degrees is in the numerator, so I need the degrees in the denominator here, so they reduce. So 180 degrees in the denominator, pi in the numerator. And then when I reduce, the degrees reduce, zeros reduce, and 32 and 18 reduce. By 2 to 16 and 9. So that leaves me with 16 pi over 9 radians. This one is in radians, so I'm going to switch it to degrees. And it's going to be negative because it starts as negative. So I've got negative 5 pi over 12 times, I need the pi to be in the denominator, so the pi is reduced. So the 180 degrees is in the numerator. So pi reduces. Let's see, 12 and 18 both reduced by 6. That would be a 2, and that would be a 30. 2 and 30 still reduce. So that's a 15 and a 1. So negative 5 times 15 is negative 75 degrees. Now this says find the exact value of each trig function. So I have the sine of pi over 6. So I'm going to draw that angle, pi over 6. So pi over 6 is 30 degrees. So this is my 60 degrees. So this one is my theta. My theta is always down here inside the angle. So that gives me 1 across from the 60, square root 3 across from the 92. So opposite, adjacent, hypotenuse. So sine is opposite over hypotenuse. So that would be 1 over 2. Now I have the tangent of pi over 4. So pi over 4, I need to change it to degrees. So degrees on the top, pi on the bottom. Pi is reduced. 4 into 180 is 45. So this is a 45, 45, 90 triangle. Across from the 45 is 1. Across from 45 is 1. Across from the 90 is square root 2. Again, my theta is always going to be down here. So the tangent is opposite over adjacent. So here's my opposite, here's my adjacent, and here's my hypotenuse. Opposite over adjacent is 1 over 1, which equals 1. So with that, we should be able to fill in all the trig functions. Because if we know our 30, 60, 90 triangle and our 45, 45, 90 triangle, we should be able to find any trig function of it. So notice I chose again sine of 30, cosine of 30, tangent of 30, then cosecant, secant, and cotangent of 30. So here's my 30 degrees. Here's my theta. This would be the opposite, this would be the adjacent, and this would be the hypotenuse. So sine of 30 is 1 over 2, opposite over hypotenuse. Cosine of 30 is adjacent over hypotenuse, so that is square root 3 over 2. Tangent is opposite over adjacent. So that becomes 1 over square root 3, which when I simplify that is square root 3 over 3. So cosecant is the reciprocal of sine. So when I flip those, I get 2 over 1, which is 2. Secant is the reciprocal of cosine. So I get 2 over square root 3, which when I multiply by square root 3, I get 2 square root 3 over 3. And cotangent is the reciprocal of tangent. So I'm going to reciprocal that, and I get square root 3 over 1, which is square root 3. So now, if I do 60 degrees, all that's going to change is where my theta is. So this is not my theta. This is still my hypotenuse, but now my theta is right here. So this becomes my opposite, and this is my adjacent. So sine opposite over hypotenuse is square root 3 over 2. Cosine adjacent over hypotenuse, so it's 1 over 2. Tangent opposite over adjacent, so it's square root 3 over 1. Cosecant is the reciprocal of 2 square root 3 over 2. So it becomes 2 over square root 3, which is 2 square root 3 over 3. Secant is the reciprocal of cosine, so that's 2 over 1, which is 2. Cotangent is the reciprocal of tangent, so it's 1 over square root 3, which simplifies to square root 3 over 3. Now, do you notice that the sine of 30 is equivalent to the cosine of 60? And the cosine of 30 is equivalent to the sine of 60. That means that sine and cosine are complementary functions. Okay, let's try our 45, 45, 90. So across from the 45 is 1, across from 45 is 1, across from the 90 is square root 2. So this is my theta. This will be my opposite, my adjacent, and my hypotenuse. So sine, opposite over hypotenuse, is 1 over square root 2, which simplifies to square root 2 over 2. Cosine, adjacent over hypotenuse, is still 1 over square root 2. So that is also square root 2 over 2. Tangent, opposite over adjacent, is 1 over 1, which is 1. Cosecant, reciprocal of sine, so I'm going to flip this one, and I get square root 2 over 1. Cosine, I'm going to flip that one, which is also 1 over square root 2, so it is square root 2. And cotangent, when I reciprocal 1 over 1, I still get 1 over 1, which is 1.